First things first, let's have a look at the translations of our graphs. Now, translating our graphs, I guess we use two formal terminologies. We either translate in the positive x direction, which means we travel left and right, or we translate in the positive y direction, which is up and down. Okay, now, if I said to you the graph of y equals x and you want to shift it up 3 units, well, most of us realise we just add 3 to it. What I want to have a look at this early stage is just a formal approach that will probably seem long-winded at the start, but when we get to more involved transformations, it'll be a nicer way to approach it. So let's concentrate on our translating parallel to the x-axis. If we think about parallel to the x-axis, we're sort of translating along like this. So if I want to move that point h units to the right, it becomes x plus h. So it's moved h units across. Okay, so if that's the case, well then let's have a think of what happens. We have the point, and we've got the point there, xy. It becomes the point, well, we added h, and y didn't change, okay? So if you like, we use dashes over here. So the new point x dash y dash becomes x plus h and y. So the notation we're going to have is, all that means is x dash, the new point, is just equal to the old point plus h, and the new y point is just equal to the old y point. And we just sort of try to come up with those two relationships, and then we can manipulate those to put them into rules when we want to try and find out what rules are. So I guess if you like, if we extend that here, we can see that x dash minus h will equal x, and y will just be equal to y dashed. So if I have a rule, y equals f of x, well, the y value there is equal to y dashed, so it becomes y dashed is equal to x, well, that's equal to x dash minus 1, f of x minus h, I should say. So you can see there, even though we're moving it in the positive direction, the new function becomes x minus h, which is, we spoke about that a bit last year, where, you know, if it's x plus 3 all squared, the turning point actually moves to the left, and if it's x minus 2 all squared, the turning point moves to the right. And it's sort of, this is the more formal explanation of why that happens. If we move down now to our translation in the y direction, very similar. We think that point xy, we're going to move it in the positive y direction. And so x doesn't change, but the y value might increase by, say, k units. Okay, so again, let's come back down in here. So let's pick our new x value and our new y value. What do they become? Well, the new x value simply becomes the old x value doesn't change, and the new y value becomes the old y value plus k units. So our little relationship here, we have x dashed is still equal to x, but y dashed is equal to the old y value plus k. So if we rearrange those, I get x is equal to x dashed, y is equal to y dashed minus k, because we take that across. So if we go back to our original equation, if say y is equal to some f of x, well then we can see the new equation, y dash, because minus k, because y is equal to y dash minus k. That's just simply equal to f of x dashed. So y is equal to f of x dashed plus k. And so you can see there's those k units we've moved up in the positive y direction. Okay, so let's have a look at an example of it and just see how that goes. The way in which I want us to approach this is, let's start off with the point xy, and what's happening? A translation of 3 units in the positive direction of the x-axis. So that means the x value has 3 added to it. And what's a translation of 2 units in the negative direction of the y-axis means it's shifting down, which means the y value has 2 units taken from it. So just to make it a little bit more sense, the new x value, so the dash just implies new. The new x value is equal to the old x value plus 3. The new y value is equal to the old y value minus 2. So I get x dashed is equal to x plus 3, y dashed is equal to y minus 2. Let's rearrange those. And the reason I rearrange those is because my equation is y equals x, not y dashed equals x dash. So now, once I've got those two relationships here, I can substitute that into any rule that I want. In this particular case, the rule that I'm transforming is y equals square root of x. So the y value is y dash plus 2 equals the square root of the x value, which is x dash minus 3. So my new function y is equal to the old function x plus 3 minus 2. Okay, so whilst we may be able to get to that point a little bit more directly without doing the x dash and y dash, I want you to practice that process so that as we move on, things become a little bit simpler.